Dassault Systemes 3D Experience World was back in February. The best part about the whole show, in my opinion, was when US CEO Manish Kumar had a press-only talk titled The Next Big Thing. In it, he explains how business can adapt to every big world event using big data. Take a look.
The question was that what is the big goal of Dassault Systems there? Where do you want to go? Maybe I can start answering that question, and that itself may lead to many more questions.
So that's where does Dassault Systems want to go?
Yeah, and my answer was world domination, of course.
Of course, and the raise for Derek. But yes, okay.
I want what? I want $1 million. Mike Myers.
Okay.
So, of course.
Other than world domination, what is Dassault Systems' objective?
Since this is 3D Experience World, so a lot of times we try to think from a design point of view, that where are we going in terms of design. So today I'm going to elevate it more from design and think more in terms of data. And I'm going to use an example that is not really fictitious, but I'm going to make it fictitious, and I shared that with a few of you. I'm not sure if you have heard that or not. Imagine you are a car company. If you are a car company, you never start to design a new generation of car from scratch. You have a bunch of car programs. You start to take a look at all your existing car programs, and then you start to see how am I going to define my next car program. So you may have a program manager who decides that 3 years from now I'm going to release my new model of my company's car. And the car program manager has to define a price at which they are trying to, or price at which they will try to sell the car at. 5 years back, 10 years, or I should say even 5 years back, pre-COVID times, because there was some stability in the market. If you predicted to do something, you could have predicted the cost. Today, the problem is that because of all the supply chain issues, you have no idea what cost of various materials are going to be, how things are going to fluctuate, and so on. So, you as a program manager, you define a program. There are engineers working in your company who are producing data. Now data can be different kind of data. Data can be, you are trying to create designs. So there are certain things which the car company will do by itself, chassis, for example. There are going to be different kind of disciplines. So for example, there are going to be electrical components there. There are going to be electronics components there. There are going to be hydraulics. So it's not just about mechanical design, it's about multidisciplinary design, I would say. On top of that, there are going to be things which are going to be provided to you by your suppliers, because no car company tries to do everything by itself. So you will have suppliers who are providing certain kind of components. There are going to be different kind of suppliers, or different suppliers who are trying to provide you similar kind of components. So you may have a lot of suppliers who can provide you possibly a headlight. A lot of suppliers who might be able to provide you sort of brake shoes and so on. So it's not going to be just one supplier, there are going to be multiple suppliers. So now, you are, and I'm going to put different scenarios. You are the manufacturing, let's say shop floor manager, the big guy who tries to define what kind of components I should be using in my program. How do you know that if some specific component you are getting out of the desired quantity of a specific component? Can you predict how you will be able to find a replacement for that? That's question number one, as a manufacturing shop engineer. The second one is as a cost engineer, or as a cost manager, let's say. There is a person who is in charge of managing the cost. They want to know that if in future the aluminum prices are going to increase by 20%, what will be the cost of my car? Think about that. How will you do that? Because It's not just about one car, by the way. It's about the entire supply line of your existing models, not just the new ones. To do that kind of analysis, you need a single source of truth where all possible components, not just created by your company, rather all the supplier components, its predictive cost, material that is being used, if price is going to increase, if the material price is going to increase, how is it going to impact the price of all those components?
Well, that's incredibly complicated.
Precisely. So I'm not done yet.
Sorry.
So now,
Please proceed.
now it's not just about the cost. So let's say you are able to find that I am able to predict that by increasing, if the aluminum price increased by a certain amount, the price of my car is going to be increased by a certain value. If I want to keep it at the previous price, what are the options that I have? The options I have are, can I find the most complicated, or can I find the component which is impacting my car in the biggest possible way? That's your question number one. Because if you can find that, then you can try to find that is there a replacement for that component? So that's question number one. Can I find the component which is going to cause me the most grief? Once you have found it out, can I find someone or some other component which can deliver the purpose with maybe some slight modifications, with some slight additional machining, but at a much cheaper price? And if I replace it, will it be able to lower my price? Not only that, is the supplier able to supply the volume of the demand that I may be able to generate? Because not all suppliers will be able to fulfill all those kind of needs. To do all this prediction, you need to have some central location of all this data. All this data has to be at some central location where you'll be able to analyze it, you'll be able to predict things, you'll be able to run. These are called what if scenarios, like what if aluminum price increases by a certain price and so on. Then you will be able to find solutions. So ultimately, and this is just the beginning part, in the sense once you have data at a single place, you can do these kind of analysis. You elevate the data to a point where you can start to extract knowledge. Then at some point it starts to become artificial intelligence, where can you start to predict what is going to happen? Can you help your users take action, preventive actions and so on? So if you ask me what is the biggest possible thing that we are trying to go towards, it's about how can we aggregate data for a given company so that we will be able to analyze your situation, be able to help you answer questions which are impossible to get answered to today. You were asking something like, it is very complicated. So yes, it is very complicated.
So how does one do that? Is that a solution? Is the platform the answer? Where does that live?
Platform is the starting point, I would say. Data aggregation is the starting point. But platform itself is not the solution, because of the data itself, to compute that material cost, for example, you need to know that every model that is in your platform has a certain level of intelligence, which means it needs to know its weight, it needs to know what material it is made out of. Then only you will be able to do these kind of analysis. So it's data aggregation is step number 0, I would say, not even 1. Once you have aggregated data, you have to start to analyze it in order to figure out what is the intelligent data, what is non-intelligent data. Can we try to analyze it further in order to make it intelligent by doing certain things? So for example, if I get a bunch of components, very similar looking components, but for some I know the weight, for others I do not know the weight, can I not predict that looking at the shape, size, volume, etc., it should be similar? For a given material, of course, because densities will change. So it's about aggregating data, it's about elevating data, it's about extracting information out of it, connecting all the dots, and then start to predict what is going to happen. The day we start to do that, that is the day when we go to the next level where we start to extract intelligence.
That sounds like you're describing agility increase for a company that finally is able to do that.
Yes.
It makes that company much more agile in its production.
Exactly.
Its innovation. It knows what it can do.
Exactly, because ultimately, if you look at our users, the data that they create, their IP is essentially embedded in that data, and the IP is embedded in the data. The intelligence is embedded in the way they have created the data. So if you go back to what Bernard was showing on day one, where give me a model or give me a scanned model, and looking at the scanned model, I'll be able to predict the intent of different areas of a point cloud and be able to create parametric feature out of it. That is also essentially extracting based on a lot of data analysis. We are able to predict what is the intent of a given collection of points, then convert that into a parametric feature. Why is it important? Because of course, if you have just a point cloud, to modify a point cloud, it's not easy. Whereas if we convert it into a parametric set of features where I know that there is a hole of a certain size, modifying it is as simple as just changing the size of, or whatever, the diameter should change from 10 to 20, it should be that simple. So, to me, we are at a very beginning phase of where we want to go.
So, is that going to live external to a company? What you're describing, that capability, what I'm getting at is this going to be for big customers that can't afford or have the resources or infrastructure to support that? Or is this something that is external to a company that they can subscribe to or participate in?
It will be a mix of both. There are, think of a material science company. I have invested a lot in the way I try to create new materials. That is my IP. If someone just takes that IP, for which I might have invested millions or billions at times, and just uses that way of producing new material, that's bad for me, right? So I do not want that to be easily accessible everywhere. So that's the extreme end. The other extreme end is where if I'm trying to select bunch of commands, what should be the next selection of my command? If I'm trying to select let's say an edge for filleting, what other edges might I need to select in order to create fillet? That is generic enough where it should be ubiquitous almost. Everyone should be able to contribute to it and everyone should be able to extract benefit from it. So there is going to be two extreme ends. It's not going to be one size fits for all. Companies like Boeing and so on, they will most likely will create their own kind of, I should say, sovereign cloud kind of environment where they will protect their IP to a point where they will know what they know, they will not allow others to know what they know. Whereas the other extreme end will be make by me that we showed this morning. Make by me is for consumers. Make by me is where anyone can create any kind of data. The makers, pretty experienced SolidWorks for makers is also in that kind of category where anyone should be able to create anything for that matter. We will provide soon enough some options if you want to contribute back to a bigger pool where we should be able to analyze it in order to predict the future. Please help us. So there will be extreme ends.
Your vision is interesting, but I think it's a past vision. It will be a good vision 1 year ago, but after the war in Ukraine, the price of electricity range maximum. Gas will be not available, and the price also increase very large. There is a problems of availability of some materials due to the war. So I think the times of the design, it's not the same times than the times of the energy and material market. And your vision is a good vision in a stable world. The world will be not stable in the next year, So how you can help the designer in order to avoid this kind of problem of disponibility of material, of energy, and the evolution of the prices.
Oh,
Because your information are based on the past, so you have to do something new.
That is a very good question. My next example was going to be that imagine there is a fire in Australia. What should you do? How would you predict that? Because maybe there is a fire in Australia, which is near a aluminum mine, which is going to make the supply of aluminum more difficult, which is going to raise up the prices, which is going to make sure, or which is going to impact your supply chain of a specific component on which you are depending on. So the day we can predict that there is a fire in Australia, you should look for a replacement of this component, is the day we become really smart. So I don't think it's a past vision. Rather, this is the vision we want to have, that how can we correlate data that is out there in the world to a point where we can start to predict things that a normal human being cannot.
But you can predict things you know. There is things you don't know. The war in Ukraine, you don't know it's happening.
But you could have predicted that if the supply of something is totally stopped, what will happen, right?
Perhaps it's the difference between the definition of prediction.
I will give one example.
Okay, go ahead.
One concrete example, and this maybe we should ask this question to Excelite and to Innovia, because I will have to find the name of the company, but this was shown at one of the 3D Experience forums, where this company has two branches, one in US and one somewhere in Europe. And they were depending in Europe, they were depending on a specific component which was getting supplied by Ukraine. In the sense, there was a factory in Ukraine which was supplying that specific component. And after the war broke out, because of this whole problem that you are saying, there was something specific which was going to be, the production was going to stop to a halt. But because these guys were in a connected kind of environment, they were able to see that what other people are using, where are these things being used, and they were able to have kind of overnight delivery from US to Europe, a certain specific amount of components, and they kept their factory running. So it's not just about, I would say, predicting totally unpredictable things like war.